Here we go. It totally crushed the can. Wow. For this experiment, make sure you have your parents near you because we're going to be using a hot plate to boil water. As always, let's gather our materials. We're going to need aluminum soda can or cans, depending on how many times you want to do the experiment. And I guarantee you it's going to be more than once. Also, make sure to rinse out all the residue out of the can so that way it doesn't mess up the experiment. We're also going to need a bowl filled with ice water, a hot plate, but also your stove can work. You're also going to want to have some water over here and also some tongs. So what we're going to do to start this experiment is we're going to grab some water. We're going to take our can and we're going to put just enough water to coat the bottom of the can. You can eyeball it. It's fine. Let me put this water, cover that up. And then what we're going to do is we're going to put it directly onto our hot plate and we're going to let it sit for about a minute. So now that the can is on the hot plate, you're going to want to bend down and kind of look. When you start seeing the steam coming out, that's when you know you're going to use your tongs and you're going to flip it over and put it into the ice. In this experiment, we first deal with our 3 states of matter: solid, liquid, and gas. Not that gas. It's getting close. Oof, the heat. It is boiling, guys, so let's let it sit for just about a minute. And then what you're gonna do right at the end of that minute, you're going to grab your tongs and go to the base of the can, and then you're gonna flip it over, making sure you do it as fast as possible and put the lip over there where the hole is. You're gonna put it down into the water, and I'll tell you why in just a minute. Here we go. Grab from the base. There we go! Awesome! Wow! It totally crushed the can. We are going to make a ghost dance using nothing but static electricity. First thing we're going to need to do is cut out a shape of a ghost in our tissue paper, but I'm going to send it off to my assistant Brooks to show you how. This happens because electrons, which are negatively charged, build up from our hair to the surface of the balloon. Did you see our scary ghost stand up and wiggle? This must mean that the ghost is positively charged, because we know when it comes to science, opposites tend to attract. We will start with a large glass. Its size should be big enough to fit a smaller glass with room to spare. Now, if you put the small glass inside, it is clearly visible because we haven't added our next ingredient. Inside these beakers will be cooking oil because light must bend to a certain degree to pass through it. The degree at which the light refracts through it is known as the index of refraction, and it will have to be particularly wide to get through the oil, which will be useful for our purposes later. The experiment begins as we fill the large beaker about 3/4 of the way up with cooking oil. As you can clearly see, the oil has the thickness and the viscosity makes a refraction of light much larger than something like water. Next, the small beaker must be pushed down into the bottom of the large oil-filled beaker. As it is pushed down, notice how the small beaker still has air and is visible, but once it is pushed beneath and the oil begins to fill it, it slowly begins to disappear. This is happening because the oil and the glass of the small beaker inside have the same index of refraction.